So in the last video, we looked at the simple numeric variables that we have in Java. So we looked at int, and then the two floating points, float and double. And again, most of the time when we want to use a floating point value, we'll just go ahead and default to using a double. So now we're going to look at strings. And unlike the other variables we saw previously, which are called primitive types, a string is actually an object, and you'll see that there's some differences in how we do it. Later on, you'll learn a lot more about objects. So we want to be able to use textual strings initially, so we'll start doing that. So I am going to go ahead and create the NetBeans project for you. This will be about the third time I've shown you this. And eventually we'll get to the point where I won't do that anymore. I'll just assume that you know how to do that. So File, New Project. I want a Java application. Hit Next. I'm going to go ahead and use my CP1 working directory so I don't have to change that with Browse. This project will be called Strings. And again, I don't want a main class. I'll hit Finish. And then within my project, I'll expand the source package. And within the default package, I'll create a new Java main class. And I'm going to call that Strings as well. And that will create a file called strings.java in my hierarchy, which is right there. It opens it. And then you can see, and again I mentioned that these names have to match. I'll go ahead and delete this little bit of note about using the template, which I don't really need. And again, I'll change this to my full name and my email. Okay. All right, so now we're ready to go. And basically a string variable or a string literal is a sequence of characters, and in Java we denote these with a double quote. So we're going to have it's called a delimiter, and we'll use the double quote to delimitate the beginning and ending of our strings. So we're going to have to declare this just like we did with our other variables. So string. And then how about, let's see, so I'll say fname for first name. And then I didn't show you this before, but you can basically declare a variable and initialize it in one step. So we can do this with the numeric variables too. So I'm going to go ahead and create a variable called fname, which is short for first name. Let me just go ahead and make that first name. So string first name equals Tom, and there we go. And then I can print this variable, SOUT, tab for system out print line. And then I'll just go first name is, and then plus first name, okay? And so you should be able to visualize what that's going to print out. So let me save that. I'll go ahead and run it and hit OK. First name is Tom. So notice I didn't get what I wanted there. So because I don't have a space here, the string Tom is appended directly. That's called concatenation, when you add one string as a suffix to another. And you notice that the plus sign when you're working with strings doesn't mean add, it means concatenate. So to fix that, I'll just put a space here. And now the space is part of this string literal. So this is a string literal. And then this string variable called first name, when I assign it, I use a string literal there as well. Okay? So let's play around a little bit here. I'm going to add another variable in. And this will also be a string. And I'll call this last name. And I'll set that equal to my last name, which is Wolf. And then basically now in my printout, I'm going to say name is first name plus last name. Okay? And you can see that now I fixed this so it won't have, will have the space here after the S. But in a minute I'm going to have another problem, which I guess I'm wondering if you can guess. So you see how Tom Wolf is all run together? So really what I want is I want a space to be in the middle of my first and last name. Now I could do that in a kind of cheater way by putting the space there. But that doesn't really make sense because the space is not part of my name. So instead, I'll put the space as a literal in here. So I'll say plus, quote, space, quote, plus. So now you can see, let me go ahead and close this so we got more screen space. There we go. So system out print line, name is space plus first name plus space plus last name. And then when I run that, you can see name is Tom Wolf. And if I wanted to make that a complete sentence with good punctuation in that, I'd have to add a period onto the end, right? So then I could just go ahead and do that. Or if I'm really excited about my name, I could add an exclamation point. So again, as I run the code, you should be kind of trying to think ahead. What's it going to be when Tom runs the program? So looking at this, it should be the same as what we just had, except there's an exclamation point on the end. And there it is. Name is Tom Wolf. Okay? So again, when we define a string variable, we have to type it just like we did with the int and the float. And so we use the string. And one thing I'll tell you now is this is a capital S. You have to watch that. The reason it's a capital is it turns out that the string is an object, not a primitive type. So int and float and double all begin with a lowercase letter because they're primitive types. But objects always begin with a capital value, a capital. Okay, so let's just do a few more things here with this. Later on, we'll see that there's all kinds of string methods that the string class has. But I'm going to go ahead and create yet another one here. So string full name equals, oh, and actually I'm not going to do this. Oh yeah, okay, let's do this as an assignment. So string full name equals first name plus last name. Okay, now notice how I have an error here. That's because I misspelled first name. And by the way, I mentioned before that we should use Camel Case in our variable name. So when we do a variable name, the first letter should be lowercase. Any subsequent word should be capitalized. So I'm using the Camel Case here. And also I'm using full variable names. Remember before I tried to make it F name, that was kind of lame, so I fixed that. So now if I come down here, I can go ahead and replace all of this with just the full name. However, I've got to remember to put that space in there. So now I'm just going to grab this real quick and paste it up in here. So now you can see that full name will be Tom plus a space plus Wolf. And then down here, I can replace all of this with full name and my exclamation point. So here we go. We'll just run this yet again. So name is Tom Wolf. Didn't change anything. I just used variables instead of literals in my expression. Okay. And generally, you should create a variable when you're going to reuse something and a literal when you're not. So for instance, name is here is not really needed to be anywhere else, so I don't have that as a variable. You can also put the whole thing in a variable too. So I could just combine all this, have string message equals name is plus full name plus that, and then system print line message. Okay? All right. Let's see, I wonder what else we should do here. We should probably combine some numbers and strings too to show how that works. So it's important to understand that if I create something like this, string not a num equals quote 1, 2, 3, 4, that is not the same as 1234. What that is that's like an address. So 1234 Oak Street, right? It's not really a number. You can't add or subtract anything to it. So that is not the same as this int num equals this. Okay, the two things are stored differently. In memory, not a num is actually a sequence of letters, a 1 followed by a 2 followed by a 3 followed by a 4, just like Tom is T followed by O followed by M. That's what a string is. It's a sequence of characters. In this case, these characters just happen to be digits. This, without the quotes, is a numeric variable. I can actually do manipulations on that. It doesn't really make sense for me to try to subtract from a sequence of digits. So you can't do any math operations on the not a number string. Okay? So I wanted to mention that. Now, occasionally we want to display values and things like that, and we want to convert a number to a string. And so it's kind of hard for me to explain why we want to do that right now because I didn't think ahead of time when I made the video. But let's go ahead and we'll just print out this. Okay, so if I tab num, that's going to print out 1, 2, 3, 4, and I can't really tell if it's a number or a string sequence. What actually happens is it converts any number to a string before it prints it out because that's how the printing works. Okay, so let's see, how can I do this? Well, okay, so again, if I print num, and then if I print, okay, yeah, here, this will work. So let's do this. Not a num. Okay, so I got a problem here. I'm telling Java to add a number and add a string to it and to print it out. So let's see what happens. So I get 1, 2, 3, 4, 1, 2, 3, 4. So what actually happens is that when I want to print a number out and I concatenate it with a string, we have what's called promotion, where Java changes the type right before printing it out. So this value here, which is actually a number, 1234, is converted to a string sequence, 1, 2, 3, 4, and then the plus sign concatenates that, so I get 1, 2, 3, 4, 1, 2, 3, 4. Okay? Now, there's a way to change a string to a number, and that's called parse int or parse float, and that is based on the type. So because this is an integer, if I say, let's see if I can get this right, integer dot and then parse int. Okay, so I'm going to parse int. So what that does is that's telling me that it's going to take the string, not a number, convert it to a number, and now what will happen is because I'm adding a number and a number, I'll get 1, 2, 3, 4 added together twice. So let's run that real quickly and I'll show you that. So you can see that that's 2,468. So it actually treated the string as a number because I used this integer.parseInt method to do that. There's also one to handle floating point numbers, and that's going to be double dot parse double, okay? And you don't really have a float, I don't think. I think you just have double dot parse double. So for instance, if I change my string up here to 12.43, and then I run my code again, let me change this, so it'll be parse double. And this is not an integer function, it's a double function. So double dot parse double. Okay, now let's run this again. And so you can see it's actually adding them together. Okay, so the double parse double converts a string representation of a floating point number to a number. And then if we want to convert a number to a string, we just concatenate a string to it. So that's kind of an interesting way, but sometimes you'll see something like this, where I'll have num plus. So what that's doing is that's a kind of a hack that converts num to a string and then prints it. Again, string should be capitalized because it's object. Okay? All right. Let's see where we're at in our time. And real quickly, I'll just show you some other stuff here. So we have some basic string functions. Let's go ahead and see if we can print out the length of a string. So salt tab, system out print line, and then that variable there I have first name. And then if I hit a dot, that brings up the various methods. So the method that we're interested in here is called the length. And if I start typing, it'll jump into the IntelliSense there, so LE, and then it brings up the length. I just hit enter and it enters it. So the length is how many characters are in the string. So we can look at Tom and we can see that we have 3 characters. And so basically this will just print a bare 3. Let's run that. And so there's the 3. And then if I wanted to make this a little prettier, I could do this. Length of Tom is plus first name dot length. Okay, and then that'll say the length of Tom is 3. Notice how again I put the space in here so that number isn't jammed right up against the S. It makes it pretty. We saw that before. So length of Tom is 3. Okay, so that's one thing that you use with strings is you can read the length, and later on we'll play around with that a bit more. You saw when I brought up the IntelliSense there's a bunch of other string functions too, and we'll go into that later. Right now I just wanted you to know the basics of the string variables, and I think the next thing we'll probably look at is how to do input, and that's one place where this ability to change a string into a number is important, because it turns out that when you use basic input, even if it's a number, you read it in as a string. So you have to convert it before you can use it in a calculation. Once we're able to do inputs, we'll be able to do significant programs like we did with our pseudocode and flowcharts. So for instance, you can write a temperature converter where you have the user give you a floating point value, and then you convert it and output the Celsius value. Okay, I hope you're enjoying this and kind of getting into your Java programming here.